Assalamualaikum warahmatullahi wabarakatuh. Welcome again to the science class by me, Cikgu Roni. Before we start our lesson, we shall recite doa. Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi zidni ilma warzuqni fahma. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa sallam walhamdulillahi rabbil alamin. So today's objective, we are talking about magnet, and the objectives are identify types of magnets, conduct or watch experiments to identify poles of magnets. Now maybe if you have magnets you can try at home, but for now in this video you shall watch experiments to identify the poles of a magnet. So the steps is, first we need to identify types of magnets that you need to learn in year 5, and then we shall identify the poles of magnets. We shall learn how to for us to identify poles of the magnets, and the thirdly is identify the properties of magnets, what magnets can do. Are you ready? Now the topic is magnets. Now the first thing, like I said, we learn about types of magnets. There are 6 types of magnets that you need to learn for Brunei Darussalam Year 5 Science. The first two is bar magnet and rod magnet. Now bar magnet, it looks like a bar, let's say, yeah, like a bar, chocolate bar. Rod magnets look like a rod, it looks cylindrical. The next two would be, okay, like one more time, bar magnet, rod magnet, and then horseshoe magnet and U-shaped magnet. So if you see, this looks like a U and this looks narrower here. The difference is this is wide and equal, straight, turn straight, and this one is closer in this side between here. So this is called horseshoe. Maybe it looks like a horseshoe, still horseshoe. And the last two magnets are button magnets and ring magnets. So next we want to learn about properties of magnets, that is poles of a magnet subtopic. Properties of magnets. All magnets have two poles. Red one is indicated by red color, and this is not Z, this is N. Turn your hand 90 degrees and you will see this is N, letter N for North Pole, and S for South Pole. Magnets have North Pole or N pole here, the red color. Magnets have South Pole or S pole, the blue color. The pull of the magnet is strongest at the poles. So here, when you see a magnet, at the end is the strongest. It have the strongest magnetic force at the end of the poles here. This end and this end, not in the middle. At the end is the strongest. So you can see by the picture, the paper clips here, here and here, it sticks on the end of the north and south pole. And here more paper clip sticks on the end of the north and south pole, and in the middle it's lesser because it does not have the strongest magnetic force. So it's the same like here, it sticks here at this end, not here, but here you will have more pull. Another properties of magnets. Okay, the first property, pull of magnet is strongest at the poles, the end of the poles here. The second property, attraction. When we bring two different magnetic poles together, they pull each other together. When it's different, S and N, it pulls, it sticks, it pulls towards each other. Unlike, poles attract. This is called unlike. Unlike in the summer. N and S, it sticks. Ia suka sama suka. So N likes S. So this is unlike poles, not the same pole, attract. Attraction of unlike poles is one property of a magnet. Another property of magnets is repulsion. Just now is attraction. Next, repulsion. When we bring two same magnetic poles together, they push each other away. Like poles, we say like poles repels. Repels means tolak, menolak. Repels, like poles repels. So N and N, if you put it closer, it will push each other. It's the same with S with S. It will push each other away. Here, lagi sekali, one more time. It's not the same N and S. It will pull, ya tarik, hampir-hampir yang melekat. It will pull each other, it attracts. One more time. Here, N sama N, and with N, it repel. It's the same with S with S. If here it is S, if you put here S, it will push each other away. I will show you later in our experiment. Next, look at this video, attraction and repulsion video. See, if you see here, there, is pushing. When this color meets that color, the same color, it pushes it away. When it's not the same color, which means it's not the same pole, it attract. Maybe one yang S, satu N. Which one? The red must be N, the white must be S. Look here. Okay, what happened there? He says that wait, one more time. It says that in this video, it says that no, forward. Okay, here. Metal ball deflected by a magnet. Here. Metal ball, this is not metal, it will move straight because the magnet does not attract non-metal. Because the magnetic ball is metal, so ya it is pull, ya tertarik, so ya jalan sana. Okay, change direction. Compass, okay, this is a compass. If you can see that, that is a compass. I will explain to you later some more. See, the compass is attracted to the magnet. Okay, I will explain to you about the compass some more later. Next, another properties of magnet. Let me change this first. Okay. When a magnet is hung freely, hung means digantung, magnet digantung, it will come to rest with poles pointing in the north-south direction. The north pole of a magnet will point to the north. The south pole of a magnet will point to the south. When we hung a bar magnet, the red side, the north side, will always point to the north, and the blue side will always point to the south. You will see in the video, this video.
How a bar magnet, when suspended, points in the north-south direction of the poles of the earth. First, we
You can
will
see here is a compass.
to find the direction of the north pole. You can see the silvery part of the compass points towards the north pole and the red part points towards the south pole. So this direction is the north-south direction. And if we use a bar magnet, the north pole of the bar magnet should point in that direction and the south pole of the bar magnet should be pointing in this direction. We will see that now. Okay, here is the suspended bar
Look,
magnet.
when you hang the bar magnet like this,
So it should finally align itself in the direction which we saw.
what happened is
That's the process. I will just
when it stops,
allow it to
the end part will always point to the north,
this way.
always.
You can see finally when it comes to rest, it points in that direction which we were talking about.
Okay, now the question is, if the bar magnet does not have color, it's just a magnet. No N, no color, no S, no color. How do you know the bar is pointing to north? I'll give you a few seconds to think. Now the answer is, remember, the sun always goes down in the west, rise up from the east, it rise up and goes down west. So from here is east, this side, and here must be west, and the sun will go here down. Sun will go up here and down here. So whatever magnet that you hang here, when you point this words, if the sun falls here, it means that that side is north. This is a second example. No, forward, forward. Take a look here. This is another experiment. There are two ways you can do this experiment. One is by hanging the magnet, and the second one is by putting the magnet Look, look, look. There's no south, no north here. Just red everything.
Note the direction.
See?
Take the magnet and turn it around and see what happens.
I think here the compass shows north is here.
The float turns again and settles in the same direction. When we compare the
It
arrow
always
pointing
stops.
north with that
If you
pointing
put it
south,
like this or hang it,
the
magnet
arrow
always
points
stop.
north
One pointing to the
in the
north
south direction.
and another one pointing
All
to the
magnets
south.
have north-seeking and south-seeking poles.
Okay, good. Let's check again. When a magnet is hung freely, digantung, or you put it on water like the video just now, it will come to rest with poles pointing in the north-south direction. One north pole will point to the north, south pole of a magnet will point to the south. Okay?
Did you know the
Now exercise. I've given you exercise in Google Form. Now you will have this type of link or a shorter link. Open Google Form. Exercise will be in the Google Form. I will not put it here. It's in the Google Form itself. The exercise, you can do that directly and you'll get your marks directly. It's like a quiz. Now before that, before exercise, we shall check magnets. We shall talk about magnets. Wait, not here. This one. Wait for a second. Order move up. Okay, I have a magnet here. If you can check here, this is a magnet. I have few magnets. I have this U-shaped magnet. I also have a few U-shaped magnets. I have ring magnets and I also have a few bar magnets. See here. Okay. Now let's test with the magnet. Now property number one, that is attraction. Unlike poles and S and wait, yeah, and S, this is North Pole, this is South Pole. So N S is called unlike poles. This is unlike poles, and unlike poles attract closer, attract. It's the same with this one. This is different than this. This is the earlier magnet. Unlike poles attract. We call this attraction. The first property is attraction. Okay. Now, if we turn around, S and S is called like poles. Yang sama like poles. Yang tadi here is not the same, so we call this unlike poles. When you turn it around, this one you call like poles, and like poles will repel. Repel means push. They push here. Aha. They push like in the video. It's the same thing with this. This is blue and this is red. So blue would indicate this, blue and blue. Okay, so these are blue and blue. Now blue and blue is unlike like poles, like poles. So if I try to stick it there, it will move away because they salah. No. Correction, one more time. Blue and blue like poles. I need like poles. Like poles do not attract each other, it push away. Blue and red, unlike poles in the summer ani, unlike. So it will stick, attract the magnet. I only have 3 types. Okay, let's check the third type. U-shaped magnet. Here. Okay. N. Okay, here. N. North pole. Like poles. This is called like poles. And like poles push each other away. They don't like each other. N and S, unlike pole, attract each other. Attract. This repel. This attract. Okay, we can see that. It's the same with if you put U-shaped magnet with U-shaped magnet is the same. So N with N, south with south, this is called like poles. Like poles repel. N with N, red with red, blue with blue. So this is unlike poles, blue, red, and they like each other, attract. Okay, we go to the next property of magnet. This is a compass. If you can see here is the arrow. The arrow is a little red in color, and that is the north. That is the north. Okay, you can see there. The north is that way, more or less. Okay, now if you understand the compass itself, the arrow is a magnet. This one, the arrow here is a magnet itself. That's why it always points to the north, like that. So when you use a magnet, north magnet, north, So the arrow, this is north and that is south. So this south will like or attract the north pole of this magnet. Any magnet, this one. Sini S, this one S, and this one N. But then when it stops, it's always point that way. And like I said, so the sun will always fall here, that side of the compass. Matahari jatuh there. The sun will rise up this side, rise up, and nighttime here. The sun will rise and goes back here. Now let's take a look. Again, one property of magnets are, let's check, sorry, the pull of magnet is strongest here. Now you can see here there's dust, I think. Nampak tu? Maybe I should use okay, I shall use light. There's light here. Okay, I'll try my best. This is a magnet. You can't really see it. There's a magnet here. Not strong enough, I think. Take a look. Maybe we can use this side on my phone. You see it properly. Use a bigger magnet maybe. It pulls the iron fillings here. Wait, where? Okay, there. It pulls it up. See. Look. Inside is iron. So the iron will follow the magnet. You see? There. It's the same with here. See? It will try to follow the magnet. Up. Compare with the middle. Here it doesn't follow as much. See, can you see inside? If you put it here, see, just a little. If you put it here, it moves. Not so much because this magnet is not that strong. Yes, that is a ring light I'm using. I have a ring light, I bought it. Let's check again. Okay. Wow. Okay, I try my best. It's okay, maybe you can try at home. But then number one, in a bar magnet like this, the pole of a magnet is strongest here. This is here is strongest. Magnet is strongest here. Magnet is strongest here. But here, not so much. I have, I think, here. Okay, wait. If I put it here, iron finding, it doesn't stick as much there. But if I put my finger here, it's clean now. See, one more time. Okay, you can see that on my finger, it's iron. If I put my magnet here, it's still there. If I put the end here, it's almost clean. And there is it. The magnet is strongest here and here. You can see that there. It does stick here, but not as much as here. Let me push it here. See, I can put it now. If it's in the middle, it doesn't stick as much. It doesn't attract as much. If it's here and I put it like this, almost nothing stick on my finger. But if I put here, something stick. So number one, magnetic force is strongest here at this end. Second, unlike poles attract, okay, like poles repel. Good. Number three, last one. When this is hang, when you hang this, the north and south will always point like that, like this compass, like that. So that is the north. Now, the best way to use a compass is do not put magnets nearby. Do not put it will disturb your compass. if you put your magnets that way, and then this way, and then that way, and then that way, you will not have a correct reading. This would be wrong. And do not put metal near your compass. Do not put metal near your compass because your compass is a magnet.
We will observe how a bar magnet, when suspended,
Sorry.
Did you notice?
Okay, let's check. Let's just go back to this one. Like I said, exercises in a Google form. The link will be provided. And let us summarize our new lesson for today. Number one, there are 6 types of magnets. U-shaped magnet, horseshoe magnet, bar magnet, rod magnet, ring magnet, and button magnet. Recap 2, lesson 2. No. Lesson recap number 2. Point number 2, like poles. This is properties of magnet. Like poles. Wrong. I'm sorry. This is wrong. This is wrong. Unlike poles attract. Unlike poles attract. Like poles repel. Sorry with the correction here. This is unlike and this is like. Unlike poles means N with S. Attract. Like poles N with N or S with S. Okay. Lesson recap 3. A free hanging magnet always resting in a north-south direction. Okay, thank you for watching science lesson topic magnets. We shall see you again on the next lesson. Assalamualaikum warahmatullahi wabarakatuh.